Chapter 4, Care and Use of Rescue Rope and Related Equipment. The knowledge objectives for this chapter: discuss how to care for rope and how to document that care. Identify the storage and use situations that could harm rope. Describe how to inspect rope. Describe how to wash rope. Describe how to dress rope ends. Describe how to care for webbing, and identify hints for rope handlers to limit rope tangling and damage. Care of ropes. The modern high-angle rescue rope is a marvel of design and engineering. A rope's performance, how long it lasts, and its safety depend on how well it is cared for. If more than one person is using the rope, keep a rope history log. Each rope must have its own log card with the following information: the manufacturer, the diameter, the design, the tensile strength, the date of purchase, and any critical data. Entries for each rope should be made after every use. Keeping a rope history log. Here's an example of another rope log. Tagging ropes. Most groups with high-angle rescue gear have ropes of similar color, length, and diameter. Each rope should have a rope tag, some distinct identification that corresponds to its card. It could be a number or letter. Storing ropes. Life safety rope must be stored in a place of its own, protected from harm. Damage can occur if the rope is left in the sunlight, exposed to vehicle exhaust fumes, or residues from storage batteries. Left on the floor, stored in wet or damp areas, stored in areas of high temperature, contaminated with dirt and grit, or exposed to potentially harmful substances. Bagging ropes. The advantages of bagging ropes is it helps protect the rope from damage, it keeps the rope clean, the rope can be flaked quickly into a bag, and provides a convenient way to carry the rope. It's also easy to deploy the rope. Here shows a couple pictures of proper way to load the rope. Ropes can easily be loaded into the bag and will cleanly deploy. Coiling. Used for storing and transporting ropes before bagging became common practice. The specific type of coil depends on the circumstances or environment in which the rope is to be used. Harmful substances. Many strong chemicals can be damaging to both nylon and polyester rope. Avoid any contact with a chemical unless you know for sure it is harmless to the rope fiber. Overloading a rope. This causes internal damage that could endanger those using the rope in the future. Damage from overloading usually occurs when a rope is used in activities for which it was not intended, or the load greatly exceeds the rope's safe working load. Damage from falling objects. Objects that fall on the rope, particularly when it's under load, can do serious damage. Anytime you see heavy or sharp objects fall directly on a rope, retire the rope, even if the damage is not readily apparent. When the rope has been used in a rock fall zone, inspect the rope for damage. Damage from abrasion. This is one of the most common means of destroying a rope or shortening its life. It's usually avoidable through the use of proper edge protection. It commonly occurs when the rope is under tension and is lowered and raised across a rock or over an edge of a building. It often happens when a person is doing bouncy rappels or ascending. Techniques for preventing abrasion. Equipment that helps prevent edge abrasion on a rope should always be carried. Rope pads can be canvas pads, heavy-duty canvas, sections of discarded fire hose, improvised rope pads, commercial rope protectors. A number of rope protection devices are available, including metal devices and soft protection. Commercial rope protectors. Other types of commercial edge protection may be similar to canvas edge pads or fire hose pads, or constructed of heat-resistant plastic. Mechanical rope protection devices. Edge rollers are one of the most effective means of protecting ropes from abrasion. Three main types of edge rollers are available: single unit rollers, roof rollers, and roll modules. Here's an image of a single unit roller. Two rollers are set into a frame. Two or more of these units usually are needed, and when stabilized, these units perform well on irregular surfaces. Here's an image of a single unit roller. Two rollers are set into a frame. Two or more of these units usually are needed, and when stabilized, these units perform well on irregular surfaces. A roof roller. This consists of a unit of 2 rollers set in a 90-degree frame, designed for edge protection on buildings and other structures where 90-degree angles are present. A roof roller. This consists of a unit of 2 rollers set in a 90-degree frame, designed for edge protection on buildings and other structures where 90-degree angles are present. Roll module. Has rollers on the side as well as the bottom. It still offers protection if the module tips over. The 4 modules are linked with screw links and can conform to a variety of surfaces. Heat fusion. This results when 2 pieces of synthetic material rub together, and it can cut a line as quickly as a knife. Everyone working in the high-angle environment must constantly be on the alert for heat fusion and take steps to avoid it. Prevent heat fusion from rope cross. Rig ropes so that they do not make contact and create heat fusion. Hold ropes away from each other with pulleys or edge rollers. Pad a stationary rope where another rope runs across it. Make sure never to place a moving rope and a stationary rope in the same edge protection device. Rope damage through flash rappels. All rappel devices operate through friction of the rope across the device. This results in the heat buildup that increases with the speed of the rappel. Fast rappels must be avoided because they can damage rope through heat buildup. Rotation of ropes used in rappel training. Handling characteristics eventually change in ropes that are in constant use for rappel training, or always anchored on the same end. When a rope is used for many rappels, the ends of the rope should be alternated as anchors. Strength loss at knots. All knots reduce the overall strength of a rope. Knots with tight bends cause greater strength loss than knots with more open bends. 4-to-1 rule. A way of estimating rope loss strength. It particularly applies to kern mantle rope. The 4-to-1 rule is strength loss in a rope does not become significant until the rope has a bend less than 4 times the diameter of the rope. Inspecting a rope. Rope inspection is an ongoing process that is performed before, during, and after rope use. Rope is inspected in 2 ways, by look and by feel. After each use, inspect your rope thoroughly by looking and feeling along every inch of its length. Inspecting a rope. When visually inspecting the rope, look for the following: any discoloration, glossy marks, exposed core fibers, they're white in most static rope, lack of uniformity in diameter and size, and inconsistency in texture and stiffness. Inspecting a rope. For the touch inspection, run the rope slowly through your bare hands and feel for the following: stiffened fibers, obvious changes in diameter, soft or hollow spots, and contamination with dirt and grit. Establishing responsibility for life safety ropes. Ropes used by a team must be assigned a chain of responsibility. Someone must be responsible for inspecting them after each use, keeping a log for each rope, and removing them from service when appropriate. Retiring a rope. Unfortunately, the only tests currently available for reliably measuring rope strength destroy the rope. Therefore, it is essential to be able to determine whether a rope should be retired. The ability is the result of the education in rope use and construction combined with experience and good judgment. Washing rope. Ropes tend to become dirty with use. Using a rope when it is dirty shortens its life. A rope should be washed only if it shows dirt. Overwashing can cause the rope to stiffen or shrink, or both. Rope washing devices. Commercial devices specifically designed for washing ropes are available. Rope washing devices are most effective against larger particles of dirt. Cleaning ropes with a washing machine. Washing machines can thoroughly and effectively clean rope. To prevent damage to the rope, these machines must be used carefully. Certain specific precautions must be taken. Coil the rope to prevent tangling. Place the rope in a mesh bag. Use gentle, non-detergent soaps and follow package directions for their use. Do not use bleaches or bleach substitutes. Use the cold water setting and rinse thoroughly. Then carefully dry the rope without heat. Fabric softeners. Ropes rinsed with a fabric softener solution should perform better than ropes washed only with soap and water. You must follow the manufacturer's instructions for this solution. This creates a softer feel for the rope, and it makes it easier to tie knots because it delays the rope stiffness that comes with age. Dressing rope ends. Cut rope ends should always be carefully dressed. Frayed ends have a sloppy, unprofessional appearance and they become snagged and eventually grow in size. Use an electric hot cutter to cut synthetic rope. Dressing rope ends. Cut rope ends should always be carefully dressed. Frayed ends have a sloppy, unprofessional appearance and they become snagged and eventually grow in size. Use an electric hot cutter to cut synthetic rope. Dressing rope ends. If you do not have a hot cutter, firmly tape the spot to be cut to prevent fraying. Cut down through the center of the tape. Immediately fuse the cut ends with heat, such as with a lighter or small flame. Care of webbing. In general, webbing should receive the same care as rope. Protect it from abrasion and damaging substances. Inspect it after each use. Webbing is more susceptible than rope to damage from shock loading. Preventing tangles. Rope does not usually come out of a coil without tangling. To ensure that the line runs smoothly in the operation, it should first be stacked. Assign a rope handler to feed the rope to the person using it. Preventing tangles. Bagged rope is less likely to tangle. Some friction devices, such as the brake bar rack, twist the rope very little, and so the rope can usually be left in the bag. Throwing and dropping rope. Large bags of rope should not be dropped. The face of the drop may not be completely vertical. In summary, a rope's performance, or how long it lasts, and its safety depend on how well it is cared for. Each rope must have its own log card with pertinent information on the manufacturer, diameter, design, tensile strength, date of purchase, and critical data. Because most groups with high-angle rescue gear have ropes of similar color, length, and diameter, a means of distinguishing each individual rope must be found so that its history can be kept. A life safety rope must be stored in a place of its own where it is protected from harm. One of the most convenient ways of storing, transporting, and protecting a rope is bagging. Many strong chemicals can be damaging to both nylon and polyester rope. Damage from overloading usually occurs when a rope is used in activities for which it was not intended and when the load greatly exceeds the rope's safe working load. Anytime you see heavy or sharp objects fall on a rope or when the rope has been used in a rock fall zone, you should inspect the rope for damage. One of the most common means of destroying a rope or shortening its life is abrasion. Damage to ropes by heat fusion can happen quickly without warning and can be catastrophic. All Rappel devices operate through friction of the rope across the device. This results in heat buildup. When a rope is used for many Rappels, the ends of the rope should be alternated as anchors to help prevent a change in handling characteristics. The general rule is that knots with tight bends cause greater strength loss than knots with more open bends. Rope inspection is an ongoing process that is performed before, during, and after rope use. Ropes used by a team must be assigned a chain of responsibility. The cost of replacing a rope is certainly less than that of a severe injury or loss of life. A rope should be washed only if it shows dirt. Commercial devices specifically designed for washing ropes are available, but may not get the surface of the rope completely clean. Washing machines can thoroughly and effectively clean rope. Ropes rinsed with a fabric softener solution that is mixed according to the fabric softener manufacturer's directions should perform better than ropes washed only with soap and water. Do not use strong solvent-based cleaners when cleaning rope. The most effective method of cutting synthetic fiber rope is to use an electric hot cutter. In general, webbing should receive the same care as rope. Rope does not usually come out of a coil without tangling. In many situations, it is not easy to get a rope from the top of a drop to the bottom.